Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 2 of lesson number 11, work and energy. So as you know, we have just started with this lesson work and energy, and part 1 was the introductory part to the lesson, right? Where I made you all aware about the basic concepts, and I have even introduced the lesson to you all, right? So now you have a bit of idea what exactly we are studying in the whole lesson, work and energy, where we will be studying about like work done on an object, about the force, about then energy, different forms of energy, discussing about kinetic energy, potential energy, right? How to derive the formula for kinetic energy. Then we have conservation of energy, and like there are so many topics under this lesson to discuss, right? So whatever topics I said, I hope every one of you are aware of the topics now, right? So you know the subtopics that we are going to study in the lesson. So now it becomes easier for you to understand the concept because you know the ABCD for the lesson, so you can like easily form the words and the sentences now, right? So the basic motto of starting with the introductory part is the same. If you know the ABCD of the lesson, you knowing the lesson, like knowing the words and the framing, the sentence becomes easier for you. So knowing the concept and elaborating in your own words will become easier for you now, right? But you have to put a bit extra effort by revising it before we start with every part, right? So I want each one of you to please revise whatever notes you took in the last part, because like I gave you many notes like about kinetic energy, potential energy, then what is work done, how will you define work, how will you define energy, what are the different forms of energy, which are the factors that affect energy, right? So there are so many points that I have made you all write, and you might have taken a note of it as well from like, right? So I want each one of you to please start revising that, and then I'll like proceed with the exact lesson. That is the first part for the lesson, which is on work. Okay. I hope every one of you are revising each and everything that you have written in your book, because you are going to like relate it somehow, and we will be starting with the part, right? See, you have to revise each and everything that you have written. Might be like you might have mistaken somewhere, so we'll be correcting them as well in every session as and when we like go with it. Okay. I'm giving you last 1 minute to revise it quickly, and then we will start with the exact lesson. Okay. So we need to start the lesson. The first concept that we have in the lesson is with work itself. Now the name of the lesson, like it says all about the lesson, because there are only two important concepts that we are going to discuss in detail. That is about work, and the other thing that we are going to study is about energy. So there are various subtopics under work and subtopics under energy that we are going to discuss with, right? So whenever we start with work, the first question that clicks our mind is, what is work? What do you think? Now, if you remember, I told you in the last session, like in first part itself, where we discussed that there is difference in the way we use the term work, right? In everyday life, like we say, I have this work to do, I have this pending work to do, right? That work is different with the one that we use over here in science. Okay, so to make this point clear, let us consider few examples. Okay, see, now, the subheading over here is not much work in spite of working hard. Now, this like seems to be bit confusing, right? So we'll discuss it so that we are clear with it. See, Kamli is preparing for examination, and she spends lot of time in studies. She reads book, draws diagram, organizes her thoughts, collects question papers, attends classes, discusses the problem with her friends, and performs experiments. And she spends a lot of energy on these activities. Okay, so she is doing so many tasks together where she is putting on so much energy, right? Because even if you are walking, you will have to spend some energy on it, right? So in common parlance, she is working hard, right? If she is working on something, she has to use a lot of energy for that, right? So in common parlance, if I say if she is doing so many tasks together, she is working hard, right? So all this hard work may involve very little work. Means if she is just drawing a diagram, the work done will be very little in that case, though we are considering to be a hard work done, but still it involves very little work. So if we go by this scientific definition of work, it's going to be different. It's not going to be like based on the task that we are doing, because as they have stated that if we are doing hard work, the work done in that case will be very little. Okay, so you are working hard to push a huge rock. Now you have a huge rock in in the surrounding, and you are working very hard to push that rock. So let us say the rock does not move despite all the efforts. Okay, What they have stated, that you're trying to push, you're like you are working hard to push that huge rock, but the rock is not moving despite of you putting so many efforts, right? So you get completely exhausted. You are completely exhausted because you are using your energy to push that rock, right? However, you have not done any work on the rock as there is no displacement of the rock. If you are doing so, like if you are pushing the rock and if the rock has not displaced, you cannot say that you have done work, though you have spent your energy and like pushing the huge rock so hard. But still you can't say that the work is done in that case. Why we can't say? Because the rock has not displaced, there is no displacement of the rock. Okay, so you stand still for few minutes with a heavy load on your head and you get tired. Now you're just standing with a heavy load on your head, and by just like standing with that heavy load, you get tired. So you have exerted yourself and have spent quite a bit of your energy. Now what you have done, you were just like you stand still, you were just standing at one place for few minutes with a heavy load on your head, right? So what you have done, you have exerted yourself because you have spent bit of your energy over here. But are you doing work on the load? No, right? You're just like you have taken it and you're standing it. So you're not doing any work in that case. So the way we understand the term work in science is work is not done. Okay? So work is not done over here, but still what happens? If there is no displacement, it means there's no work that has been done. So for if you have to say that the work is done, in that case we need to check whether is there any displacement which has been taking place or not. Okay, then we have other example as you climb up the steps of a staircase and reach the second floor of a building just to see the landscape from there. So you may even climb up a tall tree. It's just that you are climbing up. Now you are climbing up anywhere, it doesn't matter. You're just climbing up. So if we apply the scientific definition over here, you climbing up to the second floor involves a lot of work. Why? Because there is displacement means you're moving from one place to another. Like as I told you, I'm pushing the wall. Okay, I'm applying a lot of energy in pushing the wall, but because the wall doesn't get pushed, there is no displacement of the wall, right? So in that case we cannot say that the work has been done. But if I just go and climb on like to the second floor of the building, in that case I can say that I have done a lot of work. Okay, so in day to day life, we consider any useful physical or mental labor as work. Now, whatever thing that we do the whole day, we consider that to be as work. But if there is no displacement, there is no work done. So I cannot consider. Like now, you're just studying, right? You're sitting at like you're sitting at one place. You're taking notes. You're listening to me. Like you are using your energy over here. But still, scientifically, we cannot say that the work is done over here because there is no displacement. You're not moving from one place to another, right? But in day-to-day life, what we do, even we do a small work, be it physical work or mental work, we consider that to be as work, right? But scientifically it's not work. So activities like playing in a field, talking with friends, humming a tune, watching a movie, attending a function, these are sometimes not considered to be work. Why? Because there is no displacement, and what constitutes this work depends on the way we define it. So we use and define the term work differently in science. And to understand this, let us do the following activity. So we have this activity 11.1 to discuss. But before we go on to that, I want you all to please read this slide very carefully, because this is how, like this is where you will be like understanding the exact definition of the work, and you'll understand what work is. Okay, so please go through each and every point that has been stated on this slide. I hope every one of you are going through the slide, everyone. After this, now we have this activity to discuss. See, we have discussed in the above paragraphs a number of activities which we normally consider to be work in day-to-day life, right? There were so many activities that we discussed, and we used to consider that as like work in our daily life, right? So for each of these activities, ask the following question and answer them. What is the work being done on? What is happening to the object, and what is doing the work, or who is doing the work? So let's take one example over here, that is, you are standing for few minutes with a heavy load on your head. Okay, let's take that example. So now tell me, when you stand with a heavy load on your head, what is the work being done on? What work are you doing? You're just standing, right, with a stone or a load on your head. There's no work, like the work has not been done on any other object, right? Then what is happening to the object? Is anything happening to the object? No, right? It's the same. Then who is doing the work? No one is doing the work in that case, right? When you is like you are standing with a heavy load on your head, no one is doing the work. Nothing is happening to the object, and the work is not done on any of the object, neither on you, neither on the load, right? So how can you say that work is done? Then I want you all to take some examples from here and ask these three questions to yourself and check if work is been done on the object or not, what is happening to the object, and who is doing the work. I hope you all are trying it with the other activities or other work done that has been given over here. After this activity, now we have the scientific conception of work. Like as I told you, work is not something that we use, like the meaning is not the same as we use in our day-to-day life. The meaning of the work over here is different, right? So we will be discussing about the scientific conception of work over here. So to understand the way we view work and define work from the point of view of science. Now you have to keep the point of view of your mama, then your dad, of yours, everything aside, and just try to view and define work on the basis of like science. Like scientifically, let's try to define work. Okay, so let us consider some more situations which have been given over here. So the first situation that they have given is push a pebble lying on a surface. Now just imagine there's a pebble which is lying on the surface and you are like pushing it. And once you push it, you will see that the pebble will move through a distance, right? The pebble will move through a distance because you have exerted a force on the pebble. And because of the force that you have exerted, the pebble got displaced. So because there is a displacement of the pebble over here, we can say that in this situation, work is done. I'll show you, like I'll draw the thing. Suppose this is a floor and pebbles are lying on this floor. Okay, so what you did, you exerted some force on this pebble because of which the pebbles will move forward, right? Let's say they came over here. So it means the pebbles have displaced, they have changed their position, right? So we can say in this case, because there is a displacement of the pebble, work is done. So scientifically, this is how, like if I take a book from one place, if I keep it to other, in that case work will be done. But if I sit with that book and keep on reading that book, scientifically that is not a work done. Okay. Then other situation given is a girl pulls a trolley and the trolley moves through a distance. Now imagine a girl pulling a trolley, and now because she is pulling it, right? A push or a pull is a force. So what the girl is doing? The girl is pulling a trolley. So in that case you will see that the trolley will move through a distance. Okay. So over here the girl has exerted a force on the trolley and the trolley has displaced. Because if you have to define force properly, So force is nothing but it's like a push or a pull to an object. That is what force is, right? And because the girl is already like pushing it, it means she is applying or she is exerting a force on the trolley is displaced. So because it has been displaced, again scientifically we can say that work is done. Got it? Then we have lift a book through a height, and to do this you must apply a force. What you need to do? You need to apply a force, and in that case you will see that the book will rise up, right? What you do? You lifted a book through a height, like take it in your hand and just like lift up your hands up, like that kind of thing. So while you do that, you are applying a force. Because of that force you are able to rise up that book, right? So there is a force that has been applied on the book, and the book has moved, like it was like lying on the table, and from that like you have displaced it right from the table to the top of your hand. So in this case also we can say the work has been done because there is displacement. Okay, so a closer look at the above situations reveal that two conditions need to be satisfied for the work to be done. So like if you want to say that work has been done, there are two conditions that need to be satisfied, and if any of the conditions are not satisfied, we cannot say that the work has been done. Okay, so this is an important part. Like if you are considering anywhere or if you're concluding that the work has been done, you need to check on that whether these two conditions are met or not. So the first condition that they have given is a force should always act on an object. Like if you can see in this activity, they asked us about three questions. What is the work been done on? What is happening to the object? And lastly, they asked who is doing the work. So we need to check whether the work has been done on the object or not, whether the force has been exerted on the object or not, or whether the force is acting on the object or not. And second thing is, the second condition is the object must be displaced. Now in all the three situations that has been given, you might have observed that displacement makes us very much clear with the fact that work is done or not. So if displacement is there, it means work is done. If there is no displacement, in that case work is not done, right? So if any one of the above conditions does not exist, work is not done. So if the force is not acting on the object, or if the object is not getting displaced, then we will say that the work is not done. So this is the way we view work in science. Okay. Now we'll discuss about this, like a bullock is pulling a cart. So because a bullock is exerting a force on the cart, the cart moves. So there is a force on the cart and the cart has moved. So do you think that work is done in this situation? Now you have to tell me the answer for this. Do you think work has been done in this situation? Yes, definitely work has been done because the first condition that a force should act on an object. So the bullock was exerting a force on the cart, right? First condition is met, and because the cart has started moving, it means it has displaced, right? So the second condition has also been satisfied, right? So because both the conditions have been satisfied, we can conclude at the end that work is done in the situation when a bullock is pulling a cart. Okay, so now I want you all to quickly take a note of the situations which have been given and try to explain the conditions on the basis of the situation when the work has been done. Like you have to write when the work will be done and when the work will not be done, and the conditions which are required for doing that work. Okay. I hope every one of you have started taking notes. I hope you all are writing it, and you need to explain the situation why the work is not done or why the work has been done. If work is not done, like when you will consider that work to be done, everything in detail. If I'm giving you so much time, it means you need to write that in detail. Okay. After this, we have this activity 11.2, but I hope like you all are very much clear with this concept, like how scientifically we can describe work or when we can conclude that the work has been done, right? So now we will discuss this activity 11.2. See, think of some situations from your daily life involving work. Now, if you are just sitting, standing, or like studying, that is not work according to science, right? So, you have to think of some situations from your daily life which involves work, and you need to list them, discuss with your friends whether work has been done in each situation or not. And like I'll tell you, when you do that, like you will keep on laughing like for more than 15 minutes, I guess. Because till now, like even I can come up with, like I know this, but like if I say I'm teaching you all, right? So for my mom and for my dad, what I'm doing a work. But scientifically I'm not doing a work, because I'm just sitting at one place and I am like just making you learn the concepts, right? So in that case, because there is no displacement, because there is no force acting on the object, I cannot say this that I'm scientifically doing a work, right? Because I'm not doing a work. So like this is also a fun thing for me. And as soon as my mama is going to come to know this, she is like, she is going to tell me to work more harder for the household chores, you can say. Yeah, because according to them I'm doing a work, but scientifically it's not work, right? So same way you have to come up with many different life activities that you do. Like you can think of the schedule that you have, like starting from the morning till the night time till you go to bed. Think of the situations, list them down and discuss it with your friends, and you'll come to know that most of the things that we were doing, which we were considering as work, was not actually a work, right? So try to reason out your responses. And if you think that the work is done, which is the force acting on the object, what is the object on which the work has been done, and what happens to the object on which the work has been done. So for now, I want you all to come up with 3 daily life situations which you think that the work has been done. And if you think that work has been done, in that case, you need to answer these 3 questions quickly in your book. Like you need to write the situation and you need to answer the questions given on screen. Come on everyone, be quick. I hope you all are writing the situations. So this is the last part that we are discussing for today. Okay, so make sure whatever situations you're writing, it's like the correct situations. Okay, and whatever reasons that you're providing for the question that they have asked, that is also correct. Okay, so I hope you all are clear till here. Like what we had discussed today is about work, then not much work is in spite of working hard, right? Then we had discussed two different activities and the scientific conception of work. So I don't want to load you all with much of the concepts. I want you to go slow, but whatever you are studying, make sure you know the concept. You are not like rectifying anything. Okay, that is how you have to study, and that is how you need to know the concept. Now, because we have studied whatever we studied, like was easy, right? So if I tell you to write a note on it in your own words, you simply would love to do that, right? Because you have understood the concept. But if you have rectified the same concept, you'll keep on thinking what will be the point after this, and like it will be difficult as well for the same, right? So whatever we have discussed, keep on revising it. Make sure, like if possible, try to make your notes on it. You have already done it, right? So what you can do is whatever notes you took during the session, just make it as such that you can even refer it for the exam time, or if it can come up, like if you have not added any important point, you can even do that. But make sure you revise it, because revision is what I mostly focus on, right? And unless and until you're not revising it, okay, you will not understand the concept completely. You have to put your own efforts as well. See, whenever I teach you a concept, it's like you will understand it 50%, 60% of it, but once you put your efforts, you will know the concept completely. Each and every concept will be known by you properly. Okay. So now I'm going to show you like what are we going to discuss further in the lesson. So after this 11.2, we have one more activity, 11.3, and then we will be discussing on a concept termed as work done by a constant force. Okay, so we'll discuss this work done by a constant force in detail. Then we have this example 11.1 to discuss in detail. Then not 11.4, like that would be 11.4. Then we have example 11.2, where like we have numericals again. Now you know that from the past 2 3 lessons we are doing numericals over here, right? And till 8 you didn't had like numericals in your science part, right? And now you find it like difficult. I know, like even when I had my numericals for the first time in science, I was like, I'm dealing with max and I have to do the same thing in science as well. So I used to get irritated. But then what happened? A magic happened where I got a teacher where she used to like teach me the concepts properly, because of which I knew how to solve the examples. And once I knew it, I just used to love science. Okay, but before that it was like when I was rectifying the concept, and if numericals used to like come in exam, at that time I used to be like, why? Because I used to do the numericals that were there in the textbook itself, right? So if the teacher changes the number, if the teacher is changing the question, if the question is coming from somewhere out, then it used to become very difficult for me. But later, once I understood the concept, I started doing it on myself. So while you solve the example, you have to focus on the given part, what you need to find out, and then you can eventually come up with a formula. Okay, so after that, like we will be discussing on energy in detail through different activity. Then we have forms of energy to discuss. We'll be discussing on that as well, and we'll be discussing on James Prescott Joule, who exactly he was. And after that, we'll be discussing on kinetic energy in detail. Then we'll discuss on this activity 11.6, 11.7. Then we have this example 11.3 to discuss, 11.4. And after kinetic energy, we will be discussing on potential energy as well. Then we have this activity 11.8, 11.9, 11.10, 11.11, 11.12. So can you see, like, it's like bulk of activities together, but this all activities are going to actually made us, like, they will make us aware of the concepts, because it is through the activity you learn more. If I teach you the concept, it will become difficult for you, but if activities have been added, it becomes easier for you to know the concept, because these are all real life example based activities, right? So once we study this, all the concepts will become easier and clear to you. Then we'll discuss about, like, potential energy of an object at a height. So if an object is placed at a height, what will be the potential energy of that object? We'll be discussing about that. Then we have this example 11.5 to discuss, 11.6 to discuss, and after that we will be discussing on whether these energies are interconvertible or not. So we'll discuss that, and we will be discussing on activity 11.13 as well. Then we have activity 11.14, and after that we have this law of conservation of energy, which we will be discussing. And if you remember, while we were doing like part 1, I told you all that when it comes to conservation of energy, always remember that total energy will be always equal to kinetic energy plus potential energy, right? What will the total energy be equal to? Kinetic energy plus potential energy, right? So we'll be discussing that concept in detail as well. Then we have this activity 11.15 to discuss. After that, we'll be discussing on rate of doing work. Okay. Then we have this activity 11.16 to discuss, where we'll be discussing on power as well. Because when it comes to work and energy, power is ultimately been added in the concept. So we'll be discussing on power as well. Then we have example 11.7, 11.8 to discuss, and then we have commercial unit of energy. There is a unit of energy that we will be discussing on. So we'll be discussing the commercial unit of energy. Then we have example 11.9 to discuss. We have activity 11.17, and then finally the summary in short, like whatever we will be discussing in the whole lesson, we have this summary which we will be like revising and going through, so that we can have a quick revision for the whole lesson. Now you know that whenever I start the part, I start with the revision part, right? Because I feel that you knowing the revision is very important, and you doing the revision is important, right? So we'll be going through the summary, and after that we have few exercise questions to discuss. So I'm going to share the all the exercise questions with you one by one. Please make sure you all are going through the question. Okay. I hope every one of you are going through it. So these are the 21 questions that we will be discussing at the end of the lesson, work and energy. Okay, and I hope whatever we have discussed so far in the lesson, work and energy, every one of you are very much clear with it. So I will be like starting with the rest of the part for this lesson, work and energy, in the next part. But make sure, as I told you, please keep on revising it and make sure you know the concepts very well and you can even elaborate it in your own words. Okay, so I'll end this part over here. Thank you everyone.